Assalamu alaikum. Welcome to the ICSET2020. I am Mohammad Islam and the title of my paper is Imperial Mood Decomposition coupled with fast Fourier transform based features extraction method for motor imagery task classification. Let's begin. This is our outline. Our outline contains the background of our study, problem statement, the objective of our findings, methodology, and resultant discussion. Let's look at the background of my research. Brain-computer interface is a collaboration between a brain and device that enables signal from the brain to direct some external device. It enables a direct communication pathway between the brain and the object to be controlled signal due to the high time resolution and cost effectiveness of the signal acquisition. MI is widespread in BCI system because it is naturally occurring discrimination properties and also because signal acquisition is not expensive. MI enables the paralyzed people to communicate with their surrounding. There are some basic problems that happen when trying to implement this analysis. A large amount of trials is needed to train the model and achieve the high performance, which is very time consuming for calibration. The EEG data is non-stationary, non-linear, and it is very difficult to figure out the most effective features and classify this signal. The most suitable feature extraction and classification approach will increase the performance of the EEG signal. The main objective of our work is to develop the EEG signal processing platform for multi-purpose PCI application. To achieve this objective, the sub-objectives are to investigate different cognitive tasks in terms of EEG, to figure out the most effective feature extraction and classification approach for the variety of cognitive tasks, to develop a device common prototype for multi-purpose BCI application. The flowchart of the complete methodology is shown in this slide. The first step of our methodology is all data collection. The analysis outcome may hamper to identify the appropriate condition of human due to the inappropriate dataset. The data was collected from BCI Computation 3 dataset 1. This ECOG dataset took the imaginary motion of the tongue or left title finger of individual. The sampling frequency of recorded ECOG response was 1000 Hz. Our next step was the data preprocessing. For this purpose, we coupled EMD with FFT, and this combined method is finally used for feature extraction of ECOG data. After the feature extraction process, we use recursive feature elimination method. Recursive feature elimination is a feature selection method for selecting the most suitable feature with the help of reducing the model complexity and increase the model performance. Before classifying the dataset, we have partitioned the whole dataset into two groups. We use 75% dataset in order to train the model, and 25% dataset has been used for performance evaluation. Then we classified the selected feature based on three types of classification models such as SVM, KNN, and the LDA. Finally, the performance of the classifier have been evaluated using different metrics. The training data was utilized to train the classification model, and testing data is used for testing the model. The performance of this study has been illustrated in terms of testing performance. During the feature extraction, 5 EMDs have been extracted from EMD coupled with FFT technique. Initially, the full feature set from 5 EMDs have been separately employed to the three classifiers SVM, KNN, and LDA. Our next step is resultant discussion. This figure illustrated the first 5 IMFs of the sine wave. Instance mode function obtained by EMD are band limited, which can represent the feature of signal and reserve the local information. Tables show the classification accuracy of three classifiers for the full set of features from the 5 EMDs. From the table, it is clear that the support vector machine out from over the KNN LDA in the case of all EMDs. In this case of SVM, the highest accuracy obtained 83% by EMD3. The EMD4 and EMD5 obtain comparatively lower accuracy, which are 77.64% and 78.94% respectively. The reason behind the lower accuracy is supposed to the large dimension feature set where some unnecessary feature contribution to reduce the accuracy. In case of KNN, the best accuracy was 73.68% with EMD4 and EMD5, whereas the highest accuracy was 69.73% was achieved in EMD4 in the case of LDA. In order to enhance the accuracy, the recursive feature elimination algorithm has been employed to remove the unnecessary feature. Since the KNN and LDA show the completely lower accuracy, we have considered only the SVM for the feature study. These datasets consist of 64 channels and a total of 320 features have been extracted. We have calculated the classification accuracy in different number of feature sets to get the optimal feature shown in this figure. In this case of EMD5, the total number of features was 320 and the highest accuracy is 95.47% with 60 features. In the case of EMD4, the total number of features was 256 and the highest accuracy is 95.36% achieved with 60 features. In this case of EMD3, the total number of features was 192 and the highest accuracy was 95.89% with 60 features. In the case of EMD2 and EMD1, the maximum accuracy was 85.73% and 70.26% respectively with 60 features. We have further evaluated the performance of the base 3 model with different performance metrics such as precision, recall, F1 score and coherent kappa listed in this table. According to this table, the best performance was obtained with EMD3 with 60 features. In this case, the accuracy, precision, recall and F1 score and the coherent kappa are 95.89%, 0.989, 100, 100 and 0.9244 respectively. In the presented study, EMDF coupled with FFT-based feature extraction method has been employed, and the started feature has been selecting using recursive feature elimination. Finally, this selected feature have been classified using the 3 different type of classifier, including SVM, KNN, and LDA. It is not easy to analyze the ECOG signal for BCI application due to the non-stationary nature. The proposed EMDF coupled with FFT and recursive feature elimination algorithm could be an alternative to the process of non-stationary nature of the brain signal and create a new scope in BCI study. In the future, the proposed method should be validated by the more dataset to come the conclusion about the effectiveness of this method. Thank you, everyone. This is the reference of our presentation. Thank you, everyone. This is the end of our presentation.